Alright, to write a chemical formula, first of all, you will need your periodic table. Okay. In the future, we're going to learn about valencies, but valencies is basically the combining power. Let's say, for example, sodium is in group 1, so they can combine one time with another atom. Magnesium, being in group 2, they can combine 2 times with another element. Aluminium, being in group 3, they can combine 3 times with another element. So all group 1 has a valency of 1. All group 2 has valency of 2. This is 3, this is 4. Then all the noble gases, they're so unreactive, they won't combine at all. So they have a valency of 0. And then they have 1, they have 2, and then they have 3. So as you can see the trend. So group 1, so 1, 2, 3, 4, 0, 1, 2, 3, 4. Alright? So you can identify where they are and how many times they're going to combine. So what is the valency? The other one that is not mentioned in the periodic table is zinc. This one. Alright, so this one has a valency of 2. So you won't know this, you need to know it by heart. As well as for silver, it has a valency of 1. Then there's 2 more that you need to know, which is copper, which has a valency of 1 or 2. And then we have iron with a valency 2 or 3. But for these 2, they will tell you. And I'm going to give you an example. Alright, so let's start with the work. So we want to write the formula of magnesium oxide. So how do we do it? So we look for the symbol for magnesium, which is here, Mg, and it has a valency of 2. So we're going to write Mg, valency of 2. Then oxide is oxygen, which is here, and it has a valency of 2. So oxygen has a valency of 2. Now, these ratio can be simplified. So I can just say, okay, 2 by 2 is 1, 2 by 2 is 1. And then we cross it. Mean Mg, take the 1. There's no need to write 1. And O, take the 1 as well. So MgO is the chemical formula of magnesium oxide. Now, aluminium sulfide. So aluminium is Al, and it has a valency of 3. So Al, valency of 3. Sulfide is sulfur, and sulfur is here with a valency of 2. Then we cross it. Al, take the 2, and S, take the 3. Now remember, when writing Al, just be careful. This is a capital letter, and the second letter is always a small letter. Copper 2 bromide. So copper is Cu. Now you don't need to look for the valency from the periodic table because they already tell you about the Roman numbers here, which is a 2. So copper has a valency of 2. So 2. Bromide is bromine, which is Br, and Br is here with a valency of 1. Then you cross it again. So Cu1, there's no need to write 1, and Br2. So that's copper 2 bromide. Now for this one, iron-free chloride. So iron is Fe. Again, you have the valency here with the 3 in Roman numbers, so the valency of iron is 3. Then chloride is chlorine with the valency of 1. Then you cross it, so Fe1, no need to put 1, and Cl3. So that's your formula for iron-free chloride. Then sodium phosphide. Sodium is Na, and it has a valency of 1. Phosphide is phosphorus. So if you look at phosphorus, it is here, it has a valency of 3. Then you cross it, and A take the 3, and P take the 1. So no need to put 1 again. The next one is gallium oxide. So gallium is here with a Ga, and it has a valency of 3. So Ga with a valency of 3, oxide is oxygen, and oxygen is here, the valency of 2. It's crossed again, Ga2, O3. So that is the first piece of work. Now for the second worksheet. So there was copper chloride. So copper is Cu. Now this here is a valency of 2, so we don't even need to look at the periodic table because we know that Roman number 2 here means copper has a valency of 2. Then chloride is chlorine. So chlorine is here with a valency of 1. So chlorine Cl with a valency of 1. Then we cross it, so Cu take 1, there's no need for 1. Chlorine take 2, so Cu Cl2. Iron-free chlorides. So iron is Fe, so we already know that's the valency, which is a 3. Oxide is oxygen, and oxygen has a valency of 2. Cross it, Fe take the 2, and O is going to take the 3. So Fe2O3 are the chemical formula of iron-free oxide. Okay, now we come to a bit something like hydroxide, sulfate, carbonate. Now these ones, you don't really get it in your periodic table because they are groups of atoms. Alright, so to be able to do this one, you should be knowing about this. So these are called radicals. They are called radicals because they are groups of atoms. For example, sulfate has sulfur and 4 oxygen into it. So they are a group of atoms. They are unstable and they like to combine with others. So the valency tell you exactly how many times they're going to combine with another atom. For example, if we say magnesium sulfate, so sulfate will combine with 2 magnesium. And then carbonate, CO3 with a valency of 2, hydroxide, OH with a valency of 1, and so on. Now all the 8, ATE, like eat in the past tense, 8, sulfate, carbonate, phosphate, it's very confusing sometimes when we come to sulfide. So sulfide is sulfur, S. Phosphide is phosphorus, P. But sulfate is SO4. And you're not allowed to change anything in there. Phosphate is PO4. It's different. So you have to be very careful about the word. Alright? So we have these as radical. Now we're going to use this example. I would suggest you to copy this in your exercise book. It's going to be of great help. Okay, so we have, so we have sodium hydroxide. So sodium is Na, and Na is here with a valency of 1. So Na with a valency of 1. Then hydroxide, so hydroxide is OH with a valency of 1. We write it exactly the same, so OH with a valency of 1. Now, put a bracket round the radicals, round the groups of atoms. But in this situation, we're going to remove the bracket. So let's see how it works. So Na is 1. You need to put 1. Then OH, the whole of it, take the 1. Now, because it's taking 1, I won't put the bracket. If it was a 2 or a 3, I will put the bracket. There's another example to show you this. So OH, take 1. No need for the bracket. Then magnesium hydroxide. So magnesium is Mg with a valency of 2. Alright, so magnesium, Mg, valency of 2. Hydroxide again, so OH with a valency of 1. Put your bracket again. So Mg, take the 1. I need to put 1. The whole of the OH, you write exactly the same. So the whole of the OH right? Take the 2. Now remember, so if we don't put bracket, okay, so let's say MgOH2. So if we don't put the bracket, look at the difference. One magnesium, right. So one magnesium, one oxygen, but then there's 2 here, and there's 2 hydrogen, 2 hydrogen. So the oxygen is going, there's supposed to be 2, but there's only 1. So that formula is wrong. So that's why bracket is required. Then we have aluminium carbonate. So aluminium is Al, and from the periodic table, it's a free. Here, it's a free. So free. Carbonate is CO3 with a valency of 2. So CO3 with a valency of 2. Then the bracket again. And then you cross it. So Al take 2. Then the CO3. So yeah. So Al take the 2. The whole of the CO3 take the 3. So the whole of the CO3 with the bracket take the 3. Then we have zinc sulfate. So zinc is Zn. And I said earlier, zinc you have to know it has a valency of 2. So 2. Sulfate is SO4. It's here. So SO4 is a valency of 2. So 2. Now don't forget, we can simplify. So 2 by 2 is 1, 2 by 2 is 1. So when we can simplify a ratio, like 2 and 4, or 3 and 3, or 2 and 2, you can actually simplify the ratio. Alright? So Zn take 1, there's no need for 1. SO4 take 1, so just SO4. Because then, even if we put the bracket, because it's taking 1, we don't need to put the bracket. Then we have lead 4 nitrate. So lead is Pb. We don't even need to look for the periodic table because we know that 4 in Roman numbers belong to lead. So lead has a valency of 4. Then nitrate. Nitrate is NO3 with a valency of 1. Everything is capital letters, as you can see. So in all of these radicals, all of them are capital letters. So NO3 valency 1. NO3 valency 1. Then Pb, take the 1. No need to take 1. Don't forget your bracket for radicals. So NO3, you write it exactly the same. NO3, NO3 with the bracket and everything, right? And it take the 4. All right. Next one, the last one. Magnesium is Mg with a valency of, it is in group 2, so it's here. It has a valency of 2. Don't forget, 1, 2, 3, 4, 0, 1, 2, 3, 4. All right. So yeah, so magnesium is 2. Hydrogen carbonate. So hydrogen carbonate is HCO3 with a valency of 1. So HCO3 with a valency of 1. And then again, don't forget your bracket for radical. Mg, take the 1. No need to put the 1. HCO3, exactly the same. Write it exactly the same way. And this take the 2. That's the chemical formula of it. Okay, just one thing before we end this. So for hydrogen sulfate, you see the word sulfate here? Sulfate is SO4, which is here. All right. Then in the front we have hydrogen. That's why I put the hydrogen. Now valency of sulfate is 2. Means sulfate can combine 2 times. But in this situation, sulfate already combined 1 time with hydrogen. So they are only left with 1 to combine with something else. So that's why valency is 1. Exactly same applied for hydrogen carbonate. So carbonate is a CO3. Then we have hydrogen in the front. Now carbonate has a valency of 2, but then one of them will combine with hydrogen, and we're only left with 1 empty space for 1 atom to bind with it, to combine with it. Okay? So remember, this one you need to know it by heart. And then for the valencies of the element, you just need to know that zinc has a valency of 2, silver has a valency of 1, and then copper and iron will be given to you in Roman numbers, and all of these is 1, 2, 3, 4, 0, 1, 2, 3, and then 4 again. So that should be able to help you to write any chemical formula.